The task force will now come to order. I guess it's my understanding that there's an ongoing markup in Judiciary Committee, which is competing for members' attention. I suspect they will be coming in and out over the course here. Now, without objection, the chair is authorized to declare a recess of the committee at any time. Without objection, members of the full committee not in this task force are authorized to participate in today's hearing, consistent with the committee's practice. This hearing is entitled Equitable Algorithms, Examining Ways to Reduce AI Bias in Financial Services. And the chair will now recognize himself for 5 minutes for an opening statement. Well, first off, thank you, everyone, for joining us today for what should be a very interesting hearing of the task force. Today, we're looking to explore what it means to design ethical algorithms that are transparent and fair. In short, how do we program fairness into our AI models and make sure that they can explain their decisions to us? This is an especially timely topic. It seems as though every week we're hearing stories and questions about biased algorithms in the lending space, from credit cards that discriminate against women to loans that discriminate based on where you went to school. I think a lot of these issues can be a lot more complicated and nuanced than how they are portrayed in the media, but it's clear that the use of AI is hitting a nerve with a lot of folks. For us as consumers to understand what is happening, we need to take a deeper look under the hood. First off, there are literally dozens of definitions of fairness to look at. As policymakers, we need to be able to explicitly state what kinds of fairness we're looking for and how you balance multiple definitions of fairness against each other. Because while we have fair lending laws in the form of the Equal Credit Opportunity Act and the Fair Housing Act, translating these into analog laws into machine learning models is easier said than done. It's incumbent upon us to clearly state what our goals are and to try to quantify the trade-offs that we are willing to accept between accuracy and fairness. Equally important to designing ethical algorithms, however, is finding ways to ensure that they are working as they intend to. AI models present novel issues for resource-strapped regulators that aren't necessarily present in traditional lending models. For example, AI models continuously train and learn from new data, which means that the models themselves must adapt and change. Another challenge is biased data. I'm reminded at this point of the saying from the great sage Tom Lehrer, who said that life is like a sewer. What you get out of it depends on what you put into it. And so that our AI algorithms are very similar, where the algorithms are also, like sewers, and sewage in will generate sewage out. Maybe our job on this committee is to define the correct primary, secondary, and tertiary sewage treatment systems to make sure that what comes out of the algorithms is more higher quality than what goes into them. Because AI models often train on historical data, that reflects historical biases, which we hope will disappear over time, but that means the models must correct for them as we wish today, and hopefully those corrections will become less important in the future. But as more alternative data points are added to the underwriting models, the risk that a model will use such data as a proxy for prohibited characteristics like race or age only increase. One potential solution that we keep hearing about is the idea that these algorithms or their outputs should be audited by expert third parties. As an analogy, we've all subscribed to the idea that companies' financial statements be audited by qualified accountants to assure that they're compliance with generally accepted accounting principles. Another idea is to require companies to regularly self-test and perform benchmarking analyses that are submitted to regulators for review. This recognizes that model development is an iterative process and that we need agile ways to review and to respond to changing models. These are just a few of the many good ideas that have been discussed. I'm excited to have this conversation to see how we can make AI be the best version of itself and how to design algorithmic models that best capture the ideals of fairness and transparency that are reflected in our fair lending laws. We want to make sure that the biases of the analog world are not repeated in the AI and machine learning world. And with that, I'd like to recognize the task force ranking member, my friend from Georgia, Mr. Loudermilk, for 5 minutes.
Well, thank you, Mr. Chairman. Thank all of you for being here today as we discuss this very important subject. which we're going to discuss ways to identify and reduce bias in artificial intelligence in financial services. We have talked about this issue in concept numerous times, but we have not yet gotten deep into what algorithm explainability really means. So I appreciate the chairman holding this hearing. Analytical models of AI and machine learning are best understood, at least to me, when they're broken into three basic models: descriptive analytics, which analyzes past data; predictive analytics, which predicts future outcomes based on past data; and prescribing analytics, where the algorithm recommends a course of action based on past data. There's also a fourth emerging model, which I refer to as the execution model, which automatically takes action based on other AI systems' outputs. I believe the execution model deserves the most attention from policymakers because it can remove the human element in decision making. There are a number of noteworthy recent developments in artificial intelligence that I hope we can discuss today. First, the White House Office of Science and Technology Policy recently released principles for how federal agencies can regulate the development of AI in the private sector. The intent of the principles is to govern AI with the direction on the technical and ethical aspects without stifling innovation. The principles recommended providing opportunities for public feedback during the rulemaking process, considering fairness and non-discrimination regarding the decisions made by AI applications, and basing the regulatory approach on scientific data. The U.S. Chief Technology Officer said the principles are designed to ensure public engagement, limit regulatory overreach, and promote trustworthy technology. Some private sector organizations recommend principles for companies using AI. Those include designating a lead AI ethics official, making sure the customer knows when they are interacting with AI, explaining how the AI arrived at its result, and testing AI for bias. I believe the latter two, explaining results and testing for bias, are important to ensure appropriate use of AI by private sector businesses. A basic but central part of explainability is making sure businesses and their regulators are able to know the building blocks of what went into an algorithm when it was being constructed. In other words, coders should maintain thorough records of what is going into the model when it is being trained, ranked by order of importance. This is also known as logging and can help isolate sources of bias. A similar concept is present in credit scoring. Credit scores are generated by algorithms to create a number that predicts a person's ability to repay a loan. Importantly, it is easy to figure out what is bringing someone's score up or down because the factors that go into the score are transparent. Having a long credit history brings the score up, while the use of available credit brings it down. Additionally, on-time payments are weighted higher than the number of inquiries. With that said, record keeping is a starting point and certainly is not a silver bullet solution to the explainability problem, especially with more complex algorithms. With explainability, we also need to define what fairness is. There needs to be a benchmark to compare algorithm results and evaluate the fairness of an algorithm's decisions. These kinds of paper trails can help get to the bottom of suspected bias in loan underwriting decisions. It is also important to be able to test algorithms to see if there is any bias present. If there is suspect bias, companies can take a subset of the data based on sensitive features like gender and race to see if there is disparate impact on a particular group. Aside from testing for bias, testing can also help companies verify if an algorithm is arriving at its expected results. It is also important for companies and regulators to verify the input data for accuracy, completeness, and appropriateness. Flawed data likely results in flawed algorithm outcomes. I look forward to this discussion on this issue, and I yield back.
Thank you. And today we welcome the testimony of Dr. Philip Thomas, the Assistant Professor and Co-Director of the Autonomous Learning Lab, College of Information and Computer Sciences at the University of Massachusetts Amherst. Dr. Makeda Henry-Nicky, the David M. Rubenstein Fellow for the Governance Studies, Race, Prosperity, and Inclusion Initiative at Brookings Institute. Dr. Michael Kearns, Professor and National Center Chair, the Department of Computer and Information Science at the University of Pennsylvania. Ms. Bari A. Williams, Attorney and Emerging Tech AI and Privacy Advisor. And Mr. Rayed Ghani, the Distinguished Career Professor in the Machine Learning Department at Heinz College. of Information Systems and Public Policy at Carnegie Mellon University. Witnesses are reminded that your oral testimony will be limited to 5 minutes. Without objection, your written statements will be made part of the record. Dr. Thomas, you're now recognized for 5 minutes to give an oral presentation of your testimony.
Thank you. Chairman Foster, Ranking Member Loudermilk, and members of this task force, thank you for the opportunity to testify today. I'm Philip Thomas, an assistant professor at the University of Massachusetts Amherst. My goal as a machine learning researcher is to ensure that systems that use machine learning algorithms are safe and fair, properties that may be critical to the responsible use of AI in finance. Towards this goal, in a recent science paper, my co-authors and I proposed a new type of machine learning algorithm, which we call a Seldonian algorithm. Seldonian algorithms make it easier for the people using AI to ensure that the systems they create are safe and fair. We have shown how Seldonian algorithms can avoid unfair behavior when applied to a variety of applications, including optimizing online tutorials to improve student performance, influencing criminal sentencing, and deciding which loan application should be approved. While our work with loan application data may appear most relevant to this task force, that work was in a subfield of machine learning called contextual bandits. The added complexity of the contextual bandit setting would not benefit this discussion, and so I'll instead focus on an example in a more common and straightforward setting called regression. In this example, we used entrance exam scores to predict what the GPAs of new university applicants would be if they were accepted. The GPA prediction problem resembles many problems in finance. For example, rating applications for a job or loan. The fairness issues that I'll discuss are the same across these applications. In the GPA prediction study, we found that 3 standard machine learning algorithms over-predicted the GPAs of male applicants on average and under-predicted the GPAs of female applicants on average, with a total bias of around 0.3 GPA points in favor of male applicants. A Seldonian algorithm successfully limited this bias to below 0.05 GPA points with only a small reduction in predictive accuracy. The rapidly growing community of machine learning researchers studying issues related to fairness has produced many similar AI systems that can effectively preclude a variety of types of unfair behavior across a variety of applications. With the development of these fair algorithms, machine learning is reaching the point where it can be applied responsibly to financial applications, including influencing hiring and loan approval decisions. I'll now discuss technical issues related to ensuring the fairness of algorithms, which might inform future regulations aimed at ensuring the responsible use of AI in finance. First, there are many definitions of fairness. Consider our GPA prediction example. One definition of fairness requires the average predictions to be the same for each gender. Under this definition, a system that tends to predict a lower GPA if you are of a particular gender would be deemed unfair. Another definition requires the average error of predictions to be the same for each gender. Under this definition, a system that tends to overpredict the GPAs of one gender and underpredict for another would be deemed unfair. Although both of these might appear to be desirable requirements for a fair system, for this problem, it is not possible to satisfy both simultaneously. Any system, human or machine, that produces the same average prediction for each gender necessarily overpredicts more for one gender and vice versa. The machine learning community has generated more than 20 possible definitions of fairness, many of which are known to be conflicting in this way. In any effort to regulate the use of machine learning to ensure fairness, a critical first step is to define precisely what fairness means. This may require recognizing that certain behaviors that appear to be unfair may necessarily be permissible in order to enable the enforcement of a conflicting and more appropriate notion of fairness. Although the task of selecting the appropriate definition of fairness should likely fall to regulators and social scientists, machine learning researchers can inform this decision by providing guidance with regard to which definitions are possible to enforce simultaneously, what unexpected behavior might result from a particular definition of fairness, and how much or little different definitions of fairness might impact profitability. Regulations could also protect companies. Fintech companies that make every attempt to be fair, using AI systems that satisfy a reasonable definition of fairness, may still be accused of racist or sexist behavior for failing to enforce a conflicting definition of fairness. Regulation could protect these companies by providing an agreed-upon, appropriate, and satisfiable definition of what it means for their systems to be fair. Once a definition of fairness has been selected, machine learning researchers can work on developing algorithms that will enforce the chosen definition. For example, our latest Seldonian algorithms are already compatible with an extremely broad class of fairness definitions and might be immediately applicable. Still, there's no silver bullet algorithm for remedying bias and discrimination in AI. The creation of fair AI systems may require use-specific considerations across the entire AI pipeline, from the initial collection of data through to monitoring the final deployed system. Several other questions must be answered for regulations to be effective and fair. For example, will fairness requirements that appear reasonable for the short term have the long-term effect of reinforcing existing social inequalities? How should fairness requirements account for the fact that changing demographics can result in a system that was fair last month not being fair today? And when unfair behavior occurs, how can regulators determine whether this is due to the improper use of machine learning? Thank you again for the opportunity to testify today. I look forward to your questions.
Thank you. And Dr. Henry Nicky, you're now recognized for 5 minutes to give an oral presentation of your testimony.
Chair Foster, Ranking Member Loudermilk, and distinguished members of the task force, thank you for the opportunity to testify. Am I clear now? Thank you for the opportunity to testify today. I'm Makeda Henry Nicky, a fellow at Brookings Institution, and there my research covers issues of consumer financial protection. I'm pleased to share my perspective on both the opportunities and challenges of integrating AI into financial services. As this committee knows, market interest in AI is soaring. AI technologies have permanently reshaped the financial marketplace and altered consumer preferences and expectations of banks. I want to point out a few key trends that underscore this premise. First, layering AI onto the financial value chain is unlocking enormous opportunities for banks. Consider that JP Morgan, for example, just installed a contract software that takes mere seconds to review the same number of documents that previously required about 360,000 manpower hours to complete. Second, AI is creating new surface areas for banks to cross-sell products to customers, and this means more revenue. Finally, consumers are increasingly open to embracing AI in banking. According to Adobe Analytics, 44% of Gen Z and 31% of millennials have interacted with a chatbot. And they prefer overwhelmingly to interact with a chatbot as opposed to a human representative. Taken together, these trends suggest that AI is undoubtedly shaping the future of banking. The story of AI in financial services is not all bad. Innovative fintech, have made salient contributions that make financial services more inclusive and more accessible to consumers. Microsavings apps, for example, have empowered millions of consumers to save more and to do so automatically. Digit has used machine learning to help its clients save over $2.5 billion. That's an average of $2,000 annually. In credit markets, a combination of machine learning and alternative data is slowly showing some early promise. When I say alternative data, I'm not referring to the format of your email address. I'm talking about practical alternative factors such as rental payments, utility payment histories, among others. A 2019 FinReg study showed that these variables can reliably predict a consumer's ability to repay. Furthermore, the results of CFPB's No Action Letter review also supports this idea of early promise. According to CFPB, Upstart, through its use of machine learning and alternative data, was able to increase loan approvals by nearly 30% and lower APRs by as much as 17%. Crucially, the Bureau reported that the fintech's data showed no evidence of fair lending disparities. Meanwhile, a UC Berkeley study found that algorithmic lending substantially decreased pricing disparities and eliminated underwriting discrimination for Black and Hispanic borrowers. Both research and market evidence show that despite the risks, algorithmic models have potential to provide benefits to consumers. However, it's important not to overstate this promise. We have all had a front row seat to the movie, Algorithms Propagate Bias. This is not an attempt to exaggerate. Numerous cases from various scenes support this claim, from Amazon's hiring algorithm shown to be biased against women, to Google's insulting association between African Americans like myself and gorillas. And the same Berkeley study I mentioned earlier found that algorithmic lenders systematically charged Black and Hispanic borrowers higher interest rates. According to the study, minorities paid 5.3 basis points more than their white peers. In the final analysis, machine learning was not sophisticated enough to break the systematic correlation between race and credit risk. In the end, these borrowers pay an estimated ongoing $765 million in excess interest payments instead of saving or paying down student loan debt. Machine bias is not inevitable, nor is it final. This bias, though, is not benign. AI has enormous consequences for racial, gender, and sexual minorities. This should not be trivialized. Technical solutions alone, though, will not reduce algorithmic bias or ameliorate its effects. Congress should focus on strengthening the resiliency of the federal consumer financial protection framework so that consumers are protected. Thank you for your time, and I look forward to your questions.
Thank you. And Dr. Kearns, you're now recognized for 5 minutes to give an oral presentation of your testimony.
Thank you for the opportunity to testify today. My name is Michael Kearns, and I'm a professor in the Computer and Information Science Department at the University of Pennsylvania. For more than 3 decades, my research is focused on machine learning and related topics. I've consulted extensively in the finance and technology sectors, including on legal and regulatory matters. I discuss the topics in these remarks at greater length in the recent book, The Ethical Algorithm. The use of machine learning for algorithmic decision-making has become ubiquitous in the finance industry and beyond. It is applied in consequential decisions for individual consumers, such as lending and credit scoring, in the optimization of electronic trading algorithms at large brokerages, and in making forecasts of directional movement of volatility in markets and individual assets. With major exchanges now being almost entirely electronic, and with the speed and convenience of the consumer internet, the benefits of being able to leverage large-scale, fine-grained historical data sets via machine learning have become apparent. The dangers and harms of machine learning have also recently alarmed both scientists and the general public. These include violations of fairness, such as racial or gender discrimination in lending or credit decisions, and privacy, such as leaks of sensitive personal information. It is important to realize that these harms are generally not the result of human malfeasance, such as racist or incompetent software developers. Rather, they are the unintended consequences of the very scientific principles behind machine learning. Machine learning proceeds by fitting a statistical model to a training data set. In a consumer lending application, such a data set might contain demographic and financial information derived from past loan applicants, along with the outcomes of granted loans. Machine learning is applied to find a model that can predict loan default probabilities and to make lending decisions accordingly. Because the usual goal or objective is exclusively the accuracy of the model, discriminatory behavior can be inadvertently introduced. For example, if the most accurate model overall has a significantly higher false rejection rate on black applicants than on white applicants, the standard methodology of machine learning will indeed incorporate this bias. Minority groups often bear the brunt of such discrimination, since by definition, they are less represented in the training data. Note that such biases routinely occur even if the training data itself is collected in an unbiased fashion, which is rarely the case. Truly unbiased data collection requires a period of what is known as exploration in machine learning, which is rarely applied in practice because it involves, for instance, granting loans randomly, without regard for the properties of applicants. When the training data is already biased, and the basic principles of machine learning can amplify such biases or introduce new ones, we should expect discriminatory behavior of various kinds to be the norm and not the exception. Fortunately, there is help on the horizon. There is now a large community of machine learning researchers who explicitly seek to modify the classical principles of machine learning in a way that avoids or reduces sources of discriminatory behavior. For instance, rather than simply finding the model that maximizes predictive accuracy, we could add the constraint that the model must not have significantly different false rejection rates across different racial groups. This constraint can be seen as forcing a balance between accuracy and a particular definition of algorithmic fairness. The modified methodology generally requires us to specify what groups or attributes we wish to protect and what harms do we wish to protect them from. These choices will always be specific to the context and should be made by key stakeholders. There are some important caveats to this agenda. First of all, there are bad definitions of fairness that should be avoided. One example is forbidding the use of race in lending decisions in the hope that it will prevent racial discrimination. It doesn't, largely because there are so many other variables strongly correlated with race that machine learning could discover as proxies. Even worse, one can show simple examples where such restrictions will in fact harm the very group we sought to protect. Unfortunately, to the extent that consumer finance law incorporates fairness considerations, they are usually of this flawed form that restricts model inputs. It is usually far better to explicitly constrain the model's output behavior, as in the example of equalizing false rejection rates in lending. I note in closing that while my remarks have focused on the potential for designing algorithms that are better behaved, they also point the way to regulatory reform, since most notions of algorithmic fairness can be algorithmically audited. If we are concerned over false rejection rates disparities by race, we can systematically test models for such behaviors and measure the violations. I believe that the consideration of such algorithmic regulatory mechanisms is both timely and necessary, and I've elaborated on this in other recent writings. Thank you.
Thank you. And Ms. Williams, you are now recognized for 5 minutes to give an oral presentation of your testimony.
Chairman Foster, thank you. Members of the committee, thank you for allowing me to be here. My name is Bari A. Williams. I am an attorney and startup advisor based in Oakland, California. My educational background, I have a BA from UC Berkeley, an MBA from St. Mary's College of California, an MA in African American Studies from UCLA, and a JD from UC Hastings College of the Law. Primarily, I work in technology transactions, and that also includes writing all of the terms of service, which are what I like to call the things that you scroll through and then accept. I write all the things that people typically tend not to read. So I also focus on privacy and a specialization in AI, and my previous employer, All Turtles, is akin to an AI incubator, and there I concentrated not just on legal and policy, but also helped with product production and inclusiveness. So in my work in the tech sector, I've been exposed to many different use cases for AI, and the things that you tend to see them for now, a lot of the panelists have also referred to them: criminal justice, lending, understanding predictive behavior, and it's also responsible for all of the ads that you tend to see to influence consumer behavior. So I would say that there are 5 main issues with AI in financial services in particular. And one, what data sets are being used? And to me, I distill that down to who fact checks the fact checkers? What does it mean to use this particular data set, and why are you choosing to use it? 2, what hypotheses are set out to be proven by using this data? Meaning, is there a narrative that is already being written and you're looking for examples in which to prove it and to bake that into your code? 3, how inclusive is the team that is building and helping you test this product? I think that's one thing that has yet to be mentioned on the panel, is also how inclusive is the team that's actually creating this product? So who are you building the products with? 4, what conclusions are drawn from the pattern recognition in the data that the AI provides? So that's who are you building the products for? And so then who is harmed and who stands to benefit? And 5, how do we ensure bias neutrality? And are there even good reasons to ensure that there's bias neutrality? Because not all biases are bad. So data sets in financial services are used to determine your home ownership, your mortgage, your savings and student loan rates, all of the things that the prior panelists also noted. I also cited the same study that Dr. Henry Nicky did as well from UC Berkeley, by noting that, yes, she is correct in that 2017 study. It showed that 19% of Black borrowers and almost 14% of Latinx borrowers were turned down for a conventional loan. And additionally, the bias was not removed whether it was a face-to-face interaction or it was done using the algorithm. So in fact, it just seems that the AI technology actually made the efficiency better to deny people loans and to increase their interest rates. So there are 2 mechanisms in which you can drive for fair outcomes. Again, you can pick your favorite definition of fair. I think you will see that there are many to choose from. One is to leverage statistical techniques to resample or reweigh a data sample to reduce the bias. I would give you a visual of, essentially it's someone standing on a box. Imagine someone may be shorter, and you give them a box to stand on so that they're the same height as the person next to them. That's essentially reweighing the data. And the second technique is a fairness regulator, which is essentially a mathematical constraint to ensure fairness in the model to existing algorithms. So what are other emerging methods or ways that you can use AI for good? Some emerging methods, there's one in particular that's seen with Zest Financial, which is a tech company, and it's created a product called ZAML Fair, and it reduces bias in credit assessment by ranking an algorithm's credit variables by how much they lead to biased outcomes. And then they muffle the influence of those variables to produce a better model with less biased outcomes. So if more banks or even consumer-facing retailers, credit reporting bureaus used something like this, you may get a better outcome that shows better parity. So what ways can existing laws and regulations help us? It's the same as I tell my kids, is what I tell my clients: a rule is only as good as its enforcement. So if you act as if the rule doesn't exist, it might as well not exist. So an example, if a lending model finds that older individuals have a higher default rate on their loans, and then they decide to reduce lending to those individuals based on their age, that can constitute a claim for housing discrimination. That's where you could apply the Fair Housing Act. Additionally, the U.S. Equal Credit Opportunity Act of 1974, if you show greater disparate impact on the basis of any protected class, you could also use that as a lever as well. And I don't abide by the idea that, oh, well, the model did it. there are people that are actually creating the models, and so that means that there's regulation that could be used to actually ensure that the people creating the models are inclusive and diverse as well. Thank you.
Thank you. And Mr. Ghani, you're now recognized for 5 minutes to give an oral presentation of your testimony.
Thank you. Chairman Foster, members of the committee, thanks for giving me the opportunity and for holding this, this hearing. My name is Raed Ghani. I'm a professor in the Machine Learning Department and the Heinz College of Information Systems and Public Policy at Carnegie Mellon University. I've worked in the private sector and academia and extensively with governments and nonprofits in the US and globally on developing and using machine learning and AI systems for public policy problems across health, criminal justice, education, public safety, human services, and workforce development in a fair and equitable manner. AI has a lot of potential in helping tackle critical problems we face today, from improving our health and education of our children, to reducing recidivism, to improving police-community relations, to improving health and safety outcomes and conditions in workplaces and housing. AI systems can help improve outcomes for everyone and result in a better and more equitable society. At the same time, any AI system affecting people's lives should be explicitly built to increase equity and not just optimize for efficiency. An AI system designed to explicitly optimize for efficiency has the potential to leave more difficult or costly people to help behind, resulting in increased inequities. It's critical for government agencies and policymakers to ensure that AI systems are developed in a responsible, ethical, and collaborative manner with stakeholders that include, yes, developers who build these systems and decision makers who use these systems, but critically including the communities that are being impacted by them. Since today's hearing is titled Equitable Algorithms, I do want to mention that contrary to a lot of thinking in this space today, simply developing AI algorithms that are equitable is not sufficient to achieve equitable outcomes. Rather, the goal should be to make entire systems and their outcomes equitable. Since algorithms are typically not and shouldn't be making autonomous decisions in critical situations, we want equity across the entire decision-making process, which includes the AI algorithm, but also the decisions taken by humans using inputs from those algorithms and the impact of those decisions. In some recent preliminary work we did with Los Angeles City Attorney's Office, we found that we can mitigate the disparities that a potentially biased algorithm may create to potentially result in equitable criminal justice outcomes across racial groups. Because an AI system requires us to define exactly what we want it to optimize and which mistakes we think are costlier financially or socially than others, and exactly by how much, it forces us to make some of these ethical and societal values explicit. For example, a system recommending lending decisions, we may have to specify the differential costs of different errors, flagging somebody as unlikely to pay back a loan and being wrong about it, versus predicting someone will pay and not pay back a loan and being wrong about it. And specify those costs explicitly in the case of people who may be from different gender, race, income, and educational backgrounds. While that may have happened implicitly in the past and with high levels of variation across different decision makers, loan officers in this case, or banks, with AI-assisted decision-making processes, we're forced to define them explicitly and ideally consistently. In my written testimony, I outline a series of steps to create AI systems that are likely to lead to equitable outcomes that range from coming up with the outcomes to building these systems to validating whether they achieve those outcomes. What's important to know that these steps are not purely technical, but involve understanding the existing social and decision-making processes, as well as require solutions that are collaborative in nature. I think it's critical and urgent for policymakers to act and provide guidelines and regulations for both the public and private sector organizations using AI-assisted decision-making processes in order to ensure that these systems are built in a transparent and accountable manner and result in fair and equitable outcomes for society. As initial steps, we recommend, 1, expanding the already existing regulatory frameworks in different policy areas to account for AI-assisted decision-making. A lot of these bodies already exist: SEC, FINRA, CFPB, FDA, FEC, pick your favorite three-letter acronym, but these bodies typically regulate inputs that go into the process. Race or gender may not be allowed, and sometimes the process, but rarely focus on the outcomes produced by these processes. We recommend expanding these regulatory bodies to update the regulations to ensure they apply to AI-assisted decision-making. We also recommend creating training programs, processes, and tools to support these regulatory agencies in their expanded responsibilities and roles. It's important to recognize that AI can have a massive positive social impact, but we need to make sure that we can put guidelines and regulations in place to maximize the chances of the positive impact while protecting people who've been traditionally marginalized in society and may be affected negatively by these new AI systems. Thank you for this opportunity, and I look forward to your questions.
Oh, thank you. And I now recognize myself for 5 minutes for questions. Dr. Thomas, the Equal Credit Opportunity Act, also known as ECOA, prohibits discrimination in lending based on the standard factors, race or color, religion, national origin, sex, marital status, age, and the applicant's receipt of income from any public assistance program. Today, is it technically possible to program these explicit constraints? I mean, if Congress gives exact guidance as to what we think is fair, are there still remaining technical problems? And I'd be interested in the whole. Yeah, proceed.
Yes, so we could program those into algorithms. For example, the Seldonian algorithms we've created, for most definitions of fairness, we could encode them now. The remaining technical challenge is just to recognize that often fairness guarantees are only with high probability, not certainty. So it may not be possible to create an algorithm that guarantees with certainty it will be fair with respect to the chosen definition of fairness, but we can create ones that will be fair with high probability. Yes.
Any other comments on that general problem? Is it just a definitional question we're wrestling with, or are there technical issues that are on? Dr. Kern?
I mean, if I understood you correctly, as per my remarks, I think all of these definitions that try to get to fairness by restricting inputs to models are ill-formed. You should specify what behavior you want at the output. So, when you forbid the use of race, you forget the fact that, unfortunately, in the United States, zip code is already a very good statistical proxy for race. So what you should just do is say, don't have racial discrimination in the output behavior of this model, and let the model use any inputs it wants.
Yeah, Mr. Gunn?
I would just add.
Yeah. Oh, yes.
I would add that in optimizing for one definition of fairness, sometimes we're actually creating a disparate treatment effect within the protected class group. So one study showed that when they optimize for statistical parity, meaning same outcome for both groups, no differences, they actually herd qualified members of a protected class. And so there is a very costly decision involved in constraining for one definition and hurting people in the real world.
Mr. Ghani?
I think to that point, you can always achieve whatever definition of fairness that in terms of the outcomes you care about. The question is at what cost, right? And so a lot of ways you can make fairly random decisions, and a lot of random decisions will be somewhat fair, but the cost will be in terms of effectiveness of outcomes. You're not going to get to people who need the support, who need the help, who need the loans, who need the services. So the question is, it's not whether the algorithms can achieve fairness. Yes, they can. Does the cost that comes with, is that acceptable to society and to the values that we care about?
Yeah, Mr. Williams?
I would also add that this goes back to the point that I made about a narrative looking for facts. And so we want to be careful that, to Dr. Kern's point, I think solving for the outcome is actually probably most effective. The inputs are very important, yes, but also you are typically picking those inputs because there's a desired outcome that you want, and that's why you're choosing the data sets that you're choosing. And so there also needs to be an element of making sure that you're examining and auditing the human behavior that is responsible for the decision-making based off of that output as well. It isn't enough to just look at just simply the model and the inputs, but it's looking at the output, choosing to solve for the desired output, and then looking at the human decision-making behind how that comes to be.
And in the issue of whether you can just do black box testing, just look, not look at the details of the algorithms, is that an appropriate stance for us to take in regulating this? This is something that we run into in things like regulating high-frequency trading, where they're very protective of the source code for their trading, and they say just look at the trading tapes and look at our behavior and don't ask us how we come to that behavior. Is that going to end up being sufficient here, or would the regulators have to look in the guts of the algorithm? Dr. Thomas?
That'll depend on the chosen definition of fairness. So if the definition of fairness is that you don't look at a feature like race, which is the kind that Professor Kearns is arguing against, If it was that kind of definition, you may need to look at the algorithm because it could be looking at some other features that make it act as though it was looking at that protected attribute. But if you're looking at a definition of fairness like the ones Professor Kearns is promoting, things like equalized odds or demographic parity, which are requiring false positive and false negative rates to be bounded, those you could test in the black box way of looking at the behavior of the system and then determining if it's being fair or not without looking at the code for the algorithm.
Yeah, Dr. Kearns?
I think one can go a long way with black box testing. It's always better to be able to see source code. I think it's also important to remember that sometimes when we talk about algorithms or models, we're oversimplifying. A good example is advertising results on Google. So underneath advertising results on Google is indeed a machine learning model that tries to predict the likelihood that you would click on an ad, and that goes into the process of placing ads. But there's also an auction being held for people's eyeballs and impressions, and these two things interact. And so, for instance, there have been studies showing that sometimes gender discrimination in the display of STEM advertising in Google is not due to the underlying machine learning models of Google, but rather to the fact that there's a group of advertisers willing to outbid STEM advertisers for female impressions.
I will now have to bring the gavel down on myself for exceeding my time, and the chair will now recognize the distinguished ranking member for 5 minutes of questions.
Thank you, Mr. Chairman. Thank you all for incredible testimony. Spending 30 years in the information technology sector, I've learned one thing, is if you're going to take a scientific approach to anything, you can't use your own bias, but you have to suspect bias. Many times I've gone to dealing with cybersecurity issues, programming security on physical networks, and it doesn't work the way I thought it was supposed to work. Several times I went in to check myself and found out what I suspected was supposed to happen isn't what was happening. In other words, my own bias of I program it for this outcome, but the machine was actually giving me the proper outcome. The only reason I say that is if you're going to take a scientific approach, you have to check your own bias as well. So when I ask some questions here, don't interpret what I'm trying to say. We have to understand that we all have bias. And we also have to look are there occasions when the output isn't what we expected, but it is the right output? And the only reason I'm going down that, because I'm going to ask some questions just to try to help us get to where are we seeing the bias? And I'm not going into questioning or making a statement that yes, AI is perfect and it is working the way it should be, that there's anything wrong with the testimonies. I think as a community we have to come together and we realize that this is the future we're going to, and we have to get things right. And so I just wanted to say that if I ask questions, don't take it that I'm trying to question the validity of what you're telling me. I need to dig a little deeper in some of this. Ms. Henry-Nicky, as we're all concerned about potential bias in algorithms, we know from a scientific approach, humans have much more potential for bias than machines, if properly utilized and programmed. I think that's where we're getting. Ms. Williams said something in her testimony that just highlighted, I just kind of want to step through some things to see if we can really drive into where the issue exists. In her testimony, she was talking about home mortgage disclosures, and it showed that, and I believe, if I'm right, Ms. Williams, this was AI approving home mortgages, is that correct? And I think it was like only 81% of blacks were approved and 76% of Hispanics were approved. So my question, Dr. Henry-Nicky, is how do we know that those numbers weren't correct? In other words, was a 19% disapproval of black bars and 14% of Latinos outside of what would normally we see if it wasn't through through an algorithm?
It's difficult to answer that question without looking at the algorithms, but I'll tell you that it's not fair to assess what a proper outcome should be. The context matters.
Right.
And so if the market bears an average denial rate of 19%, then that's the market. And so if both groups, Hispanics, African Americans, and white borrowers are being denied at systematically similar rates, then that's an outcome that I don't think we can argue with. What's troublesome or concerning,
Move the microphone, yeah, they're
Sorry.
very directional microphones here.
what is troublesome or concerning in that kind of example would be a model that's systematically denying minority borrowers, and having that be based on their race or predicted by their race. So
Right.
I think it's, and we've said it all in the panel, looking squarely for computational technical solutions is part of the answer,
Right.
but it's not the complete answer. We need a systematic approach to making sure that we can understand, what's going on in these algorithmic applications, and also from there to monitor effects and, most importantly, processes.
And so when it comes to testing AI platforms, it's not just the algorithm. There's a whole lot of emphasis on the algorithm, which is a mathematical equation. That's one part of a four-part testing that we need to do. The appropriateness of the data, the quality of the data, the availability of the data. You also have cognitive input systems that have to be considered. If it's using facial identification for something, is that actually operating? So the reason I'm asking the questions is to say, are we focused on an algorithm when the problem may actually be in the data, or the appropriateness of the data if there is, and we just will make the assumption for this argument, that the output of the AI system is wrong. But I also think we do have to have empirical data to prove that the output is wrong and it's not in our own bias. And I'm not suggesting that that's what it is, but from a scientific approach, we have to do that. In a forensic way, if we're going to find out where the problem is we have to consider all that. And so if we have a second round, I'll have more questions. Thank you, Mr. Chairman.
I anticipate that. The gentleman from Missouri, Mr. Cleaver, who's also the chair of the Subcommittee on National Security, International Development, and Monetary Policy, is recognized for 5 minutes.
Thank you, Mr. Chairman, and thank you for calling this hearing. Dr. Thomas, what is AI? Can you, as quickly as short a definition as you?
Unfortunately, it's a poor definition, but AI, I view it as just a research field that contains a lot of different directions towards making machines more intelligent so that they can solve problems that we might associate with intelligent behavior.
Machine intelligence.
Yes.
Okay. So if Netflix begins to have showings for certain viewers, customers, and they know what movies and shows that I would most likely enjoy, what determined that? How did they get that information? Is that AI?
Yes, typically that would be machine learning, which is a subfield of AI that uses data collected from people, for example, to make decisions or predictions about what those people will like in the future.
Okay, thank you. Any of our witnesses? I was on the committee when we had the economic collapse in 2008, and we, witness after witness, testified clearly, unambiguously, that there was great intentionality in the discrimination in mortgages with black and brown people. I mean, they admitted it. Can AI, Ms. Williams, eliminate that or confuse it even more?
It has the potential to do both. I'm sorry, I'm giving you a very lawyerly answer, right? It depends. It literally can do both. My concern, a ranking member made a comment in regards to his question around is how do we know that this isn't the right answer based on the data that is received? Well, the answer to that, I would say, which is also analogous to your question, is if you are using historical data, the historical data already is biased. So if we're talking about something that's based on redlining or something that's based on income of women or income of Black people in particular, we know that we are historically underpaid, even if we have the same credentials and qualifications and experience. So if you're using bad inputs, you're going to get bad outputs. It's very akin to what Congressman Foster said, is it's garbage in, garbage out. So it has the potential to solve for it if you are also being cognizant of the fact that not all biases are bad, so there may be some ways to solve for it, particularly the human decision-making element at the end of when you get the output, but the inputs also need to be completely vetted and understood as well. So again, if you're using something that's based off of old redlining data, that's already going to skew your results.
And to any of you, it does, you know, one of the most dangerous things I contend, having grown up in the Deep South, is unconscious bias. And so, I mean, there would be people who would, without any hesitation or reservation, declare that, you know, I have designed this machine, and the algorithms are completely unbiased. Is that even possible? Anybody? Yes, sir, Mr. Guy.
No, I don't think anybody is trained or certified today to the level where they can guarantee that an algorithm is unbiased. And I think we're focusing, the focus on the algorithm is I think misleading. I think it's important to remember that algorithm doesn't do anything by itself. You tell it what to do.
Yeah.
So if you tell it to replicate the past, that's exactly what it will do. So you can take bad data, but tell it, don't replicate the past, make it fair. Here's what I mean by fair. Even if that doesn't work, and as you know, my fellow panelist was saying, the decisions we take based on the algorithm's recommendation, we don't have to do exactly what the algorithm says. We can override in certain cases when the algorithm gives us the right explanation, which we need that, and override it and or reinforce what it's doing based on what our societal outcomes are. Mm-hmm. So we need training for regulators to understand these nuances, because today we don't have that capacity inside agencies to understand this, implement it, and enforce these types of regulations that should exist regardless of AI. I mean, what we're talking about is not about AI, right? It's about societal values that should exist in every human decision-making process. We're just talking about it today because the scale and the risks might be higher, but it's the same conversation that should have been happening continuously.
My time has run out, but we had someone before this committee once who declared that he had never seen any discrimination and didn't know anything about it. He's 60 years old, but he said he knew some people who had. Thank you.
Thank you. And the gentleman from Virginia, Mr. Riggleman, is recognized for 5 minutes.
Thank you, Mr. Chairman. Thank you, everybody, for being here. And had a whole list of questions, but now that I've heard you guys, I'm just going to ask some cool things. And Dr. Thomas, I was really impressed by your thoughtful words about contextual bandits. When I did this, I had to worry about technical or assumed bandits because we actually tried to template human behavior for node linking or information sharing and how they actually put that data together. And we had 2 or 3 people. And by the way, when we templated each other's behavior, it was completely different. It was fantastic. But that's the algorithm we tried to do. So I have a question for you on these contextual bandits, because as soon as you said it, I'm like, oh goodness, I've never heard that term specifically. We always just called them screw-ups. You know, is there a list of contextual bandits that might be overlooked or not seen as egregious? And is there a prioritized set of rule set errors that you and your team or others have identified that we can point to and go look at? So, you know, because for instance, we had our huge list of errors that we had in our algorithmic rule sets that we were building, you know, through machine learning. But is there any? Have you guys identified this list, or is there a list that we can see as far as those contextual bandits you're talking about?
I think we may have a miscommunication on the term contextual bandits. By contextual bandit, I mean the machine learning paradigm where you make a decision based on a feature vector and then get a reward in return for it, and you optimize that. Is that the same usage of the phrase that you're using?
A little different. Nope, you're right. Because when you said contextual bandit, I'm thinking about a bandit where you had a faulty piece of data put into your rule set, and that faulty piece of data came from somebody's context on what that piece of data should do. So is there any way, so let me then reframe the question. Is there any way to identify or is there a playbook or a technical order on how to remove some of those contextual bandits that say we as a committee can see or that we can refer to?
Unfortunately, I'm not particularly familiar with the specific definition of contextual bandit that you're using, so I
Okay,
can't answer this. I apologize. Bandits in our setting refers to kind of like slot machines as being called a one-armed bandit.
Oh, okay, all right. I thought you were talking about pieces of data with it. I'm sorry about that, because I'm like, damn, darn, I'm using contextual bandits for now on. That's the greatest term I've heard in a long time. So how do you, and Dr. Kearns, you know, I was listening to what you were saying. Where have improvements been in removing bias been most noticeable when you're looking at building, you know, these rule sets? Where have you seen that we've done the most improvement right now? And again, is there something that I can go see? Because I know our issues that we had in the DoD. Where can I go see where the most improvements for removing bias and a way forward for us as we do this?
Yeah, I guess in my opinion, there's quite a bit of science on algorithmic fairness, and we sort of broadly know how to make things better right now. But it is, in my view, early days in terms of actual adoption. And I think one of the problems with adoption is that, for instance, even though many of the large tech companies have small armies of PhDs who think specifically about fairness and privacy issues in machine learning, there's been relatively few actual deployments into kind of critical products at those companies. And I think that's because of the aforementioned costs that, you know, I and my fellow panelists have made, right? You know, if you impose a fairness constraint on Google advertising or in lending, that will inevitably come at a cost to overall accuracy. And so in lending, you know, a reduction in overall accuracy is either going to be more defaults or fewer loans granted to creditworthy people that would have given revenue. And I think the next important step is to sort of explain to companies, either, you know, by coercion or encouragement, that they need to think carefully about these trade-offs, and that we need to start talking about making these trade-offs quantitative and kind of acceptable to both industry and to society.
And I think, Dr. Henry Nicky, when you were talking about this, now that we went to trade-offs, do you feel that, can it go the other way? Can we have too many trade-offs when it comes to bias? And can we insert things in there that might not be real based on a political decision? I think that's the thing that everybody here wants to keep out of this, is that where is that line between making sure, do we have an algorithm writing on an algorithm for fairness, which is what we tried to do, was to write an algorithm to cross-check our algorithms? Or do we have to be very careful about what we identify as bias or fairness when we're making these rule sets? And where is that trade-off, you know, as far as, can we go too political where it doesn't become fair based on the fact we're too worried about what fairness looks like?
I think it can become too political. When the CFPB tried to implement its BISG to make auto lending fair, it went extremely political and ended up, you know, screwing consumers.
Yeah.
And so I think we have to step back, collectively decide, regulators, the scientific community, consumer advocates, technologists, and public policy scholars try to think about how do we create collective gradations of fairness that we can all agree with. It's not a hard and fast issue, and as Dr. Thomas said and Dr. Kearns, more fairness. But you heard some groups who, in protected classes, who were better off anyway before the algorithms were imposed.
Thank all of you for your thoughtfulness. Oh, sorry, I know my time. I know my time's almost up, but a little bit of time. I think it's up, right?
Yeah, there's an unofficial 40 seconds of slop time. So you're now
Thank
down
you.
to 18.
You're a gracious man. Thank you, sir.
So just to make one brief comment to make the political realities clear here. Pick your favorite specific mathematical definition of fairness and consider two different groups that we might want to protect, by gender and by race. It really might be the case that it is inevitable that when you ask for more fairness by race, you must have less fairness by gender. And this is a mathematical truth that we need to get used to.
No, thank you for that clarification. Thank you for your thoughtful answers. I appreciate it.
Thank you. And
Yield back.
the gentleman from Illinois, Mr. Caston, is recognized for 5 minutes.
Thank you, Mr. Foster. I'm just fascinated by this panel, and I find myself thinking that I have deep philosophical and ethical questions right now that are really best answered in the context of a 5-minute congressional hearing, as all of our philosophers have taught us. I do, though, think there are some seriously philosophical questions here, and so I'd like you just to think as big picture as you can, and hopefully as briefly as you can. First, Dr. Cairns, I was intrigued by your comment to Mr. Foster, that we shouldn't define bias on the basis of inputs. I'm just curious, do any of the panelists disagree with that as a proposition? Okay, so then Dr. Cairns, help me out with the second layer. is it more useful to define the bias in terms of outputs or in terms of how the outputs are used? Because I can imagine an algorithm that predicts where a crime is likely to occur at point X. I can imagine using that for good to prevent the crime. I can imagine to use that to trade against in advance of the crime and make money off of it. How would you define the point of regulation or internal control where we should define that bias?
Okay, that's a great question. It's not an easy one. First of all, it can't possibly hurt to get the outputs right in the first place. Second, there are many situations in which the output is the decision. So, criminal sentencing is an example where, fortunately still, the output of predictive models is given to human judges as an input to their decision-making process. But lots of things in lending and other parts of consumer finance are entirely automated now. So there is no human that's like overseeing, that the algorithm actually makes the lending decision. So there you need to get the outputs right because there is no second point of enforcement. In general, I think, as per comments that people have made here already, it is true that we shouldn't become too myopically focused on algorithms and models only because there's generally a pipeline, right? There's a process to collect data from before, early in the pipeline, and there might be many steps that involve, human reasoning down the line as well. But to the extent that we can get the outputs fair and correct, that's better for the downstream process than not.
So then the point of how it's used. Hold on a second, because I got two more meaty questions, and like I said, all these are like PhD thesis questions. Ms. Williams, you said that in your comments that not all biases are bad. Do you have any really easy definition of how we would define good versus bad bias if we're going to go in and regulate this?
That's a good question. It is giving me college throwback ideas. I guess it would be if you have certain outputs that show disparate impact among groups for, let's say, certain housing decisions over the course of, let's say, 3 generations. If you somehow put that into your inputs, or if you use that, if you are a human decision maker who receives an output and you decide that that's something that you're going to try to correct for or solve for, then perhaps that is an example of bias for good.
All right, so my last really meaty one, I'm going to give you the really hard one, Dr. Henry Nicky. Let us stipulate that people will make decisions based on bias. They will make money off that decisions based on bias because they already have. Like, we already know that that's going to happen. From a regulatory perspective, what do you think is the appropriate thing to do after that's happened? Because are they obligated to disclose? I mean, I know of cases where hedge funds have found that they were actually trading on horrible things in the world and the algorithm got out of control. Should they disclose that? Should they return the gains that they've had of that? Should they reveal the code? What do you think, if you're the philosopher king or queen, what's the right way for us to respond to something having agreed that should never have happened?
Well, I think our current regulatory framework allows for that situation, and it allows us to revisit the issue, analyze and understand who the population that was hurt, what they look like, how much disgorgement we should go back and get in terms of redress for consumers. So I think it's completely appropriate to go back and right the harms for consumers who've been hurt.
But doesn't that assume that they've already disclosed it, right?
Well,
if in my scenario where my algorithm is predicting a crime and I figure out how to short the crime.
Disclosure does not absolve you of liability.
Yeah, but if you're not obligated to disclose, how are we ever going to find out as regulators that it happened?
I think that's a really good question. If you're not obligated to disclose, then we are in a catch-22. And then how do we find and identify and detect? And how do we hold them accountable? I think it's important to have CFPB, DOJ, OCC, and the Federal Reserve have their enforcement powers intact and strengthened to be able to hold bad actors, regardless of intent, accountable for their decisions.
Well, I'm out of time. I yield back. I'm sorry, Mr. Yanni, I know your hand was up. Feel free to submit comments. And if any of you have thoughts on that, please feel free to submit. Thank you so much.
Yes, and I believe it's likely that if we don't have votes called, we're likely to get to the second round of questions. The gentleman from North Carolina, Mr. Budd, is recognized for 5 minutes.
Thank you, Chair. So, fascinating conversation, Professor Ghani, was there something that you were, I think your hand was raised earlier. I have other questions for you, but if you wanted to clarify.
Yeah, I wanted to go back to the first PhD thesis that was talked about. Is it enough to get the outputs right, or is it important how those outputs are going to be used? And I think it's probably the most critical question that's been asked today, because it doesn't matter what your outputs are if you don't act on them appropriately, right? So here's an example. If you're going to take the example of, you're not going to get all the outputs right, period. AI will never be good enough to get perfectly everything right? So then the question is, it's going to make mistakes. What mistakes are more important to guard against? Really depends on how those outputs are going to be used. If we predict somebody might commit a crime, and the intervention we have is going and arresting them, that's a punitive intervention. False positives are bad. Like disproportionate false positives are much, much, much worse than missing people. If we predict that somebody's going to commit a crime, but they have a mental health need, and we're going to send out a mental health outreach team to help them, give them the support services they need, then missing people disproportionately. False negatives are much, much, much worse than false positives. And so the intervention is what really decides how we design these algorithms, and it's not the output. You can have the same output. Different interventions will require different notions of what to optimize for and the impact of the bias in society. So I want to make that distinction clear.
Thank you.
It does matter quite a bit.
Thank you. And in terms of using this AI for giving people credit, I think we can agree that giving consumers access to credit can fundamentally change their lives. And this is one tool that we're using that can help them do so. It allows consumers to buy a home, car, pay for college, start a small business. Using alternative data such as education level, employment status, rent, utility payments, it has the potential to expand access to credit for all consumers, especially those on the fringes of the credit score range. A recent national online survey shows that 61% of consumers believe that incorporating access to their payment history in their credit files would ultimately improve their scores. The same survey also found that more than half of consumers felt empowered when able to add their payment history into their credit files, and they cited the ability to access more favorable credit terms as one of the biggest benefits of sharing their financial information. So can you further elaborate, Mr. Ghani, on how the use of alternative data expands access to credit for low to moderate income consumers who would otherwise be unable to access that same credit?
Yeah, I mean, I would go back to what Dr. Kern was saying was it's really not about the inputs, right? So the sandbox we need to create is to enter those things in and then measure the outputs and then look at disparities in the rates at which you're going to offer loans or credits to people that you wouldn't have before. So imagine our societal goal is that the lending decisions we want to make should serve to reduce or eliminate disparities in home ownership rates across, let's say, black and white individuals or minorities and white individuals. If that's the societal goal we want to have, then these inputs may or may not help us achieve that. And what we want to be able to do is to test that out, have a framework for testing it, validating it, certifying that's actually doing that, and then put this into place after we've done trials, just like other agencies, regulatory agencies do. So you can't start with starting with, if we put these inputs, would it help? We don't know. But I think putting the right outcomes in place that you want to achieve and then testing it is the right approach to take.
So
I would add to that.
I'm going to add an open question here, and this is if you can comment on the same thing, but then answer the open question, and that is ways that we can be more encouraging to use tools like alternative data and AI and access to raise access to credit and lower the overall cost for consumers. If there's ways that we can encourage that here, so please.
I'll take that question first. I think we have to be careful about experimenting with consumers' financial lives. I think a healthy way to discover what are new products that are out there might be through pilots, might be through continued active observation, and also vigilant oversight, as in the Upstart case. To your question before, how do rental payments help to expand access to credit as an alternative data? So for example, in some markets, rental payments are as high as a mortgage or even higher. And if you, as a first-time home buyer about to enter into this process, have only had a rental payment history that is consistent, stable, not late, then taking that feature, substituting it for what a mortgage payment, and standing in for a mortgage payment, could then push you above the margin to have the model predict that you are a good credit risk.
Thank you, and I yield back.
Thank you. Let's see. Yeah, the gentleman from Indiana, Mr. Hollingsworth, is recognized for 5 minutes.
Well, good afternoon. I appreciate everybody being here. Certainly, were my wife here, she would tell you that I am far outside my circle of competence. So I'm going to ask a lot of really stupid questions and let you guys give me really intelligent answers to those stupid questions. Can you clarify, the word fairness has been thrown around a lot. Can you clarify what you guys mean by fairness? The 5 of you. Yeah, have at it. Dr. Kearns, Ms. Williams, Dr. Thomas, everybody, anybody.
Okay, I'll go first.
Okay.
For me, I look at fairness as ensuring that all groups have equal probability of being assigned favorable outcomes.
All groups have equal probability of being assigned outcomes irrespective of their current situations, or all individuals similarly situated are assigned the same outcome, the same probability of outcomes?
The latter.
The latter, okay. Dr. Kearns?
I mean, there are too many definitions of fairness, as we've already alluded to, but
Yeah.
the vast majority of them, begin with the user has to identify what group or groups they want to protect,
Yeah.
and what would constitute harm to those groups. So it's
Yeah.
maybe a racial minority, and the harm is a false loan rejection for a loan that they would have repaid.
Well, you've clearly short-circuited to what I was getting at, which is, right, we have a lot of senses of fairness and a lot of senses of what we want done, but the requirement in AI and algorithms is that we make explicit that which is right now implicit, right? And you have to be really good at making that explicit, because the algorithm itself is going to optimize for what you tell it to optimize for, right? And so you're going to have to make very clear what you were trying to optimize for in order to get that outcome, and then what, to your point, what side you are unwilling to live with, right? I'm unwilling to live with the extra risk on this side or perhaps that side, depending on what situation you're in. So not only do you have to have a lot of awareness about exactly what you want to optimize for, but also a lot of awareness about, in the context, what you're really worried about and what you're concerned about, the false positives or the other side of it. Dr. Thomas?
Sorry, I fully agree with this. Was there,
Yeah.
I missed what the precise.
No, I saw you nodding your head and didn't know if you had a comment to the previous question
I
about
generally
fairness.
just in agreement that you're hitting on very good points. And
I shall take that back to my wife. Maybe my circle of competence is bigger than I thought it was. Yeah.
you're hitting on the point that there are many different definitions of fairness. The question of which one is right and nailing it down is very important.
Yeah.
And something that I think you might be kind of dancing around is this idea that the negative outcomes that are consistent with different definitions of fairness can often all seem bad. There can be two different definitions of fairness, and if we pick one, it means we're saying that the undesirable, unfair behavior of the other is necessarily okay.
Yeah, and I think Dr. Kearns talked a little bit about this earlier, and it's something that puzzles me a lot, because I think in some places, right, the trade-off in fairness for one group may mean less fairness in the other. Did you say that, Dr. Kearns, I think?
I did.
Yeah, and this is something that others have hit on as well, that we are going to have to grow comfortable saying to ourselves, we are going to trade fairness here for fairness there, and not just more fairness for perhaps less accuracy in the model itself, which is something we have had more comfort in, but trading fairness and risk to a certain group is something we've been really uncomfortable with, because we want fairness for everybody in every dimension, which seems, I don't want to say impractical, but it seems challenging inside an AI algorithm and optimization.
I would say that is, in fact, impractical.
Yeah, okay, great.
And let me just, while we're in the Department of Bad News,
Yeah.
let me also point out that all these definitions that we're discussing are basically only aggregate definitions.
Right.
They only provide protections at the group level.
Right.
So for instance, you can be fair, let's say, by race in lending.
Yeah.
And if you are a black person who is falsely rejected for a loan, your consolation is supposed to be the knowledge that white people are also being rejected for falsely rejected for loans at the same rate.
Yeah.
There is a literature on individual notions of fairness, definitions of fairness that try to make promises to particular people.
Yeah.
They're basically impractical and feasible. It's sort of a theoretical curiosity, but no more.
Yeah, I appreciate that. Each of you have talked a little bit about the pipeline, that AI algorithms aren't birthed in the ether, right? That they rely on data, A, and B, individuals craft these. I wonder if you might talk a little bit about the biases that we're talking about. they likely to arise from the algorithm itself? Are they likely to arise from the coder or the drafter of said algorithm? Are they likely to arise from the data that is being input into them? Where should we look first if we're going to look through that pipeline? Ms. Williams.
I would say look on the human level first, because a human is going to discern what is the narrative that they're actually solving for, and therefore what's the data that they're going to use, and they discern the quality of data that is used, and they then discern the training set that is created and how that is functional. So I also want to be clear, I don't think that, you know, there are a bunch of mad coders sitting in a basement somewhere. Just
Nefarious activities aside.
I don't think that that's it. It's very, you don't know what you don't know.
Yeah, agreed.
And I think oftentimes it's people pick data that is available to them. They may not do a ton of due diligence to find additional data or data that may even offset some of the data that they already have. But I would say start at the human level first, because that's where everything else sort of begins in terms of picking the data, the quality of data, and then actually doing the coding.
With that, I yield back, Mr. Chairman.
Thank you. And now I guess we have time for a quick second round of questions, and so I'll vote. Oh, yeah, votes at 3:30, and we have nerves of steel here on letting, so we'll give it a try here. So I'll recognize myself for 5 minutes. I'd like to talk about the competitive situation that would happen when you have multiple companies, each running their own AI, and say offering credit to groups of people. If you just tell them, okay, maximize profits, that's a mathematically well-defined way to program your AI, and they would all do it identically, and the competition would work out in an understandable way. Now, if you impose a fairness constraint on these, so the first off, that will reduce the profitability of any firm that you impose the fairness constraint, so they're not simply maximizing profits. And now, then, if a new competitor may come in and say, oh, there's a profitable opportunity to cherry pick customers that your fairness constraint has caused you to exclude. And is that a mathematically stable competition? Has that been thought about? Do you understand the problem I'm talking about?
If I understand you correctly, there is a literature in economics on, you know, whether, for instance, racial discrimination in hiring can actually be, you know, a formal equilibrium of the Nash variety.
Maybe that's a good description.
And so Gary Becker was a very famous economist who did a lot of work in the 60s and 70s on exactly this topic. And you know, it's complicated, but the top level summary of his work is that, you know, the argument that you can't have discrimination in hiring at equilibrium because you wouldn't be competitive, right? Because you're irrationally excluding some qualified sector of the job market. He actually shows that, in fact, you can have discrimination even at equilibrium.
And so then, see, one of the questions would be whether you're better off actually having multiple players here. So if someone is erroneously excluded because some quirk in some model, then it would be to an advantage of society overall to have multiple players so that person can go to a second credit provider.
So you're asking kind of the reverse of Becker's question, I think, which is if you don't have sort of regulatory conditions on anti-discrimination, for instance, you know, might there be arbitrage opportunities for new entrants? I don't know that question has been specifically considered, but it's a good question.
So I think one thing I would point out is the premise that if you put those constraints there, the profits will go down. That's not a guarantee. We don't know that, and here's why, right? I think it was Dr. Kearns who was talking about. There are a lot of people who we don't know what happens when somebody who was never the type of person who was never given loans before. What happens when you give them a loan, right? So it could be that when you start adding these fairness constraints, it turns out that you don't actually lose profits, and in fact, you might increase profits. So these are things called counterfactuals, right? Where because you've never given loans to people like this, you don't know what the outcomes are. You might have the human decision-making process that existed before was only giving loans to people they thought were going to pay back loans.
Well, that has to do with the exploratory phase of programming your neural nets to actually do random crazy stuff because you may discover a pocket of consumers.
Hopefully better than random crazy stuff, but some smarter version of that, yeah.
Yeah, and so that's and so, you know, this question of similarly situated people, you know, that depends on the scope of the data that you're looking at, because two people can look similarly situated. if you only look at their family and their personal history, and then if you look at a wider set of things, I think this is what came up with Apple and Goldman, where if you just looked at one half of a couple's credit information, you would give a different credit limit on a credit card, I think it was. Whereas if you look holistically at both halves of a couple, you'd get a different answer. And there's no obvious right answer to how wide you should spread your field of view here. Is that an unresolvable problem that you're going to need Congress to weigh in on? Yeah.
So I think this is exactly why these systems need people in the middle, but also these systems need collaborative processes up front, including the people who are going to be impacted by them. Right? If you start including those communities, they'll tell you that. So there's actually really good work. There's a group in New Zealand who's been doing, how do we incorporate community input into designing these types of algorithms? What input attributes do we use that best represent the differences and similarities across these? So it is inherently, it's going to be hard to automate that today. But I think that's the process we need, which includes the community that's being impacted and humans in the loop in the system coming up with some of these things and collaborating with the machines.
Wow, okay, that sounds ambitious. I'm just trying to think of assembling, groups that are sufficiently knowledgeable about the nuts and bolts of this and where you're balancing the people who end up winning and losing according to the trade-offs you're going to be making.
I mean, the challenge is that some of the amount of data you have on people is also a function of who they are. So some people are more reluctant to give data about them. They have less of a history. Immigrants are coming in who don't have a background, and credit history. So missing information, it's not just that you have the data, you can just get it and compare those. If you might not have that data, and that's also biased in the data collection process.
Okay, I will gavel myself down and recognize the ranking member for 5 minutes.
Thank you, Mr. Chairman. Unfortunately, we only have a few more minutes. I think we could all be here all day discussing this. Something Ms. Williams said and Dr. Kern said earlier has really been resonating. Not all bias is bad, which we agree. In fact, if we take kind of the model we've been talking about, loan applications, whether it's mortgage or not, the whole purpose of the AI platform is to be biased, right? That's the actual purpose, is to be biased, but what is the biasness that we want? We want those who are likely to pay a loan back, really, is what we're getting at. So I think I see what you're saying. There are some bias that you want in there. What is the bias we want to eliminate is really the question, and that goes something Dr. Kern said is, well, if we reprogram it to make sure more of one racial group gets more approval, then you may see a gender impacted. And so this is kind of a conundrum we're in until we figure out or define what biasness do we want in a particular system, but more importantly, what do we not want? When I look at it as what do we not want, if Mr. Budd and myself are identical, I know that we're identical in incomes because I know what he does for a living and that the law doesn't allow him to take any other income, right? But if he's Hispanic, I'm white, and the chairman is black, and we all have the same income, we all have the same assets, we all have basically the same biographical data, do we all get the same result, whether it's approval or disapproval? That's really what I think we're trying to get to. It isn't that, well, we weren't happy with the result that came out, and if we don't, we've got to go back and find out why, and that's what we're getting at. Mr. Ghani, if it exists, and since algorithms are my mathematical equation, really, I think part of the problem is when you get into machine learning and the algorithm begins to rewrite itself, how do we track it, right? So we verify the data is good. I think most of the problem we have is probably in the data and the appropriateness of the data. Let me see, not just in the raw data, but the appropriateness of the data. But if we do want to check the algorithms, is there a way of running what I would call in the network world an audit trail in the development of the algorithm, throughout the operation of the algorithm, and each phase of decision that's making in the actual coding, and is there a way to go back and do a forensic audit trail in these algorithms?
Yeah, absolutely. And I think that's the right approach. Is you can audit the data, and that's great. But then you're gonna. So I think the starting point is, you want to tell it what you want the system to achieve. Then you want to turn those into technical requirements for the system to see what to tell it to do. Then you want to confirm that it did what you told it to do. And then you want to test it and see, does it continue to do what it did yesterday, right? So that's when you ask what should we ask a company to disclose. It's not the algorithm, it's not the code, it's not the data. It's this entire audit trail, and that's what we need to look at to figure out where it's happening.
An interesting aspect, and take it a step further, the difference between software and artificial intelligence is we expect software to give us the same result every time, right? That's not the case with artificial intelligence, correct? Because artificial intelligence is always looking for other data, and it may give us a different outcome the next day based on something that changed the day before. And it may rewrite itself to learn new things. I think that's some of the challenge going forward is if you tell the machine that is not the right answer, it's going to look for a different answer in the future. I mean, this is stuff we wrote science fiction about just 10 years ago, right? So, when we code the algorithms themselves, can we actually program in the artificial intelligence platform to do systematic reports throughout the process?
Absolutely. Okay. I mean, that should be standard. That should be part of our training programs for people building these systems. That should be part of training for auditors who are doing compliance. Absolutely, that's the right approach.
And the last part is probably more a statement than a question. As in my opening statement, I talked about different analytical models. I think the one that concerns us the most is what I call the execution model. We have presentation of data, we have predictive analysis, we have prescriptive analysis that prescribes, okay, approve or don't approve. And we can do that, but yet there's a human element making the same decision. It's like the backup warning on my car that beeps and it says something's behind me. It doesn't stop the car. I still make the decision. But if you watch the Super Bowl, the smart talk, right, it's actually making the decisions. In this case, it's the machine making the decision of go, no go on the loan. It's executing on that. And I think until we get this fixed, we may need to look at, okay, is there an appeal process for that go, no go that a human element can go in and work? So thank you, Mr. Chairman. It sounds like our warning bell's going off and my time has expired.
Well, thank you. And I'd like to also thank our witnesses for their testimony today. Without objection, the following letters will be submitted for the record. We have letters from the Student Borrower Protection Center, Kathy O'Neill of O'Neill Risk Consulting and Algorithmic Auditing, the BSA Software Alliance, the Upstart Network Incorporated, and Zest AI. Without objection, all members will have 5 legislative days with which to submit additional written questions for witnesses to the chair, which will be forwarded to the witnesses for their response. I respectfully request that our witnesses please respond as promptly as you're able. Without objection, all members will have 5 legislative days with which to submit extraneous materials to the chair for inclusion in the record. This hearing is adjourned.